At first glance, they look almost identical. Vertical bars of varying heights, a horizontal axis, and a vertical axis. In the world of data visualization, the histogram and the bar chart are two of the most common tools, yet they are frequently confused by students and professionals alike. Understanding the difference isn't just a matter of aesthetics, it's about the fundamental nature of the data you are trying to analyze. Today, we are going to dive deep into why these two charts are not the same. The fundamental difference lies in the type of data they represent. Bar charts are designed for categorical data. This refers to groups or categories that have no numerical value in themselves. Think of favorite pizza toppings like pepperoni, mushroom, and pineapple, or car brands like Tesla, Ford, and Toyota. In a bar chart, the bars represent these discrete groups. According to recent surveys in data science, over 60% of business reporting relies on categorical comparisons. Each bar is its own entity, a separate bucket for counting occurrences or measuring a specific value. On the other hand, histograms are built for quantitative data. This is numerical data that represents a measurement or a count, such as age, weight, temperature, or annual income. In a histogram, the data is continuous. For example, if we are measuring the height of 1,000 professional athletes, we aren't looking for categories, we are looking at a spectrum. Statistics show that in scientific research, histograms are the primary tool used to identify the distribution of variables, allowing researchers to see where the majority of data points cluster. One of the most immediate visual giveaways is the gap. In a bar chart, there are spaces between the bars. These gaps emphasize that the categories are separate and distinct. You can't transition from a banana to an apple. However, in a histogram, the bars usually touch each other. There are no gaps because the horizontal axis is a continuous number line. If one bar represents the range of 20 to 30 years old, the next bar starts exactly where the first one ended, at 30. This visual continuity represents the flow of numerical data across a range. This brings us to the concept of binning. In a bar chart, the width of the bar doesn't represent any numerical value. It's just a design choice. But in a histogram, the width of the bar represents the bin width, or the interval. Choosing the right bin size is crucial. If your bins are too wide, you lose the detail of the distribution, a phenomenon known as oversmoothing. If they are too narrow, the chart becomes noisy and hard to read. In high-frequency trading or data center monitoring, binning is used to categorize milliseconds of latency into readable intervals to detect performance bottlenecks. Let's talk about the order of the bars. In a bar chart, the order is often arbitrary or based on a specific logic like the Pareto principle, where bars are sorted from highest to lowest frequency. You can move the Tesla bar to the end of the chart without changing the meaning of the data. In a histogram, the order is fixed. Because the x-axis is a quantitative scale, you cannot rearrange the bars. 10 to 20 must come before 20 to 30. Moving a bar would break the mathematical logic of the entire visualization. The ultimate purpose of a histogram is to show the distribution of the data. This allows us to see patterns like the normal distribution, also known as the bell curve, where most data points are near the mean. We can also identify skewness, whether the data is leaning to the left or the right, and detect outliers. Bar charts don't show distributions in this statistical sense. They show comparisons. For instance, while a bar chart can tell you which department in a company has the most employees, a histogram of those employees' salaries can tell you if the pay structure is equitable or heavily skewed toward the top executives. In summary, remember these 3 rules. First, check the data type. Categories use bar charts. Numbers use histograms. Second, look for the gaps. Gaps for categories, no gaps for ranges. Third, consider the order. Flexible for categories, strictly numerical for histograms. Whether you are analyzing the volatility of the S&P 500 or just counting the colors in a bag of M&Ms, choosing the right chart is the first step toward accurate data storytelling. Mastering these nuances ensures your insights are not just seen, but correctly understood.